All right, so this worksheet was designed to get you to review your knowledge of inscribed shapes. So it's basically shapes that are drawn inside of the big polygon on the outside. And so it's the result of you drawing diagonal lines, right? And so you're getting a whole bunch of different shapes that we recognize, right? Like you have your trapezoid, your triangle, your pentagon, right? So what I would like you to, at this point, almost memorize, right? The interior angle of a triangle, right? Of a regular triangle, equilateral triangle would be 60. The interior angle of any quadrilateral, so I'm just going to call it quad, right? Of a regular would be 90, I should say, right? The interior angle of a pentagon is 108. And so you have a couple here to choose from, right? The sum of a triangle is 180, right? The sum of a quad is 360, and the sum of a pentagon is 540, right? If you have this kind of like in the back of your mind and always there, it makes things a lot faster, especially when you're dealing with inscribed shapes, okay? So that's something you might want to add to your study sheet. We'll see. You decide that, okay? We don't tell you what to put on there because we want you to take some initiative, right? And to basically study, go through your notes and try to take out what's important, right? So let's deal with this one on the left here first. Maybe we should call this, A and this B, so we make a distinction between them. And oftentimes it doesn't really matter where you start, but there's definitely a best way or a quickest way of doing things. So when I look at a polygon, the first thing I would do, right, look at the outside shape, right, that encompasses everything inside. I would start counting, right? So 1, 2, 3, 4, 5, 6, 7 on the outside. So n is equal to 7 here. Like determine that first and foremost, right? And you know that's a heptagon, right? Okay. So once you've determined that, almost regardless of what's inside, like what variables are asked of you, right, or for you to determine, I would find the interior angle of this because let's face it, right, the diagonals always come down and touch the interior angle. So you're going to have to find what it is to determine other things, right? So the interior angle of a heptagon would be, and I'm just going to do this the quick way already, right, without really using the formula because it's n minus 2 divided by n, right? And it is a decimal, so I'm just going to do it right beside here. Is it 128.57? I have to check. 5b7. This is the n minus 2 portion. So n is 7. So 7 minus 2 is 5. So I already do that in my head. I don't bother writing down 7 minus 2. You know what I mean? Yeah. I'm just going to check if that is... this is not the time to just go ballpark, right? You want to be exact. So 128.57, as I thought, right? So do this as your first step anyways. Find the interior angle of that big polygon that's holding everything inside. And then it happens to be that A, which they're asking you for, is actually your interior angle, right? So we can just say right away, A is equal to 128. So you've also found one of the angles that are unknown anyways. So you've done 2 and 1 there. But I would always find this one anyways, okay? So you found this one there. Next, I would find, I'm going to now focus on this diagonal here, this one here. And maybe I will use a highlighter. If I focus on this diagonal there, right, I have, now I'm using the exterior sides, right, the sides of the actual heptagon, right. I'm going to focus on this here. And that is a trapezoid right here, a quadrilateral, a four-sided, but specifically a trapezoid. So how do we find B? Let's draw this out. Okay, I'm going to sit it down like this, right? So that this is the base of this trapezoid here, and B is going to be over here. A, this one here, I already know what that is. These are the two interior angles that I found up here already, right? Because these two are the same, and these two are the same as well. That's because this is an isosceles trapezoid, right? So you're going to go 128, 57, 128, 57. Sorry, it's a little small, but right. So to find B, how do I start? Well, I can tell you already that you're going to have to divide by 2. You're going to split the difference between these two angles, right? So you start with, it's a quadrilateral, so it's going to be 360 degrees total minus 2 times the interior angle, or in our case, this was called A as well. We're going to go 128.57 like that. And you should be very careful here. I would go 360 minus 2 times 128.57, hit enter or equal, whatever you're using, because it's such a common error, right? So you go 360 minus 2 times 128.57, right, like that, hit enter, and then you go divide it by 2. So it's 51.43 is your answer for B. So 1 for interior angle, 1 mark for this, right? And because, right, I will make a note here. Right, the quadrilateral, that's why this is 360. If this had been a pentagon, you would put in 540, right? And then you would have 3 angles to subtract. It will come up here on this example on the right. Okay. Now, I'm going to shift my attention to this other shape, right? This is a diagonal right here. And I'm going to now use the actual sides of the polygon, right? So you've got this triangle here. Don't go with this one here, because then you're using 2 diagonals. You don't want to do that. Just focus on the other one and the shape that's resulting with using the actual sides of the polygon. Okay. So here, I'm not going to be able to keep that diagram on there, unfortunately. So angle C, I'll do a diagram first, because you need to see this probably. Right, if I put this as my base, the diagonal, and I want C, right, I know that this top angle here is 128.57, because in a heptagon, all the interior angles all around are the same, right, if it's a regular shape. So angle C, it's a triangle, so you start with 180 minus, and there's only 1, right, just 128.57 divided by 2. That's 25.72 rounded degrees. There you have it. Okay, so we found A, we found B using the quadrilateral. So notice that it's 360 minus 2 of the top angles. This one is 180 because it's a triangle minus just 1 of the top angle. Always divided by 2 though, right? And now we're going to find D. That's the last one we're going to do. Okay, so here I will use a different color because if you look at this vertex right here, this whole thing measures 128.57, right? Because this whole thing is the interior angle of this heptagon, right? So we start with 128.57. We know this angle here, which is the same as B, and we just found C. So if we subtract these two from 128.57, we're going to find that little sliver that's in between. Okay, so that's our last order of business. We do that here. Angle D is equal to 128.57 minus, and I will actually use angle B minus angle C so you know what's happening. So D is 128.57 minus 51.43 minus 25.72. So B and D are basically the same, right? But C isn't, right? It's just because of rounding. Had we used all the decimals here, we would have probably come up with the same angle. Okay, so that is, let me just zoom out a bit, right? That is all the work that would be associated with this polygon here. And I'm going to split this page, okay, so that I have work. So that's that, okay? Let's move over to the right side here. Okay, and here we count, right? 1, 2, 3, 4, 5, 6, 7, 8. N is equal to 8. Regardless of what is being asked of me, I'm going to go I of 8, right? The interior angle of 8 would be 6 times 180 divided by 8. And the interior angle of an 8-sided polygon, which is an octagon, is 135. Is it? I have to check. Always double check, and it is. Right? So I'm just going to underline this because it's important, but it's not, we don't know if it's answering anything yet. And it does, because A is right here. A is equal to 135. So there you have shown your work. No need to do it all over again. C, we're looking at the same, right? This is a trapezoid again, right? But this trapezoid is inside an octagon. This trapezoid was inside a heptagon, right? That's the difference. So here, we're going to go angle C would be, we have 360, because it's a 4-sided, minus, we got to subtract these two angles, which we know. These are part of the octagon as well as the trapezoid in here. So we're going to go minus 2 times 135 in this case. Watch before, it was 128.57, right? It was a different interior angle. Now it's 135, and we divide that by 2. Okay. So angle C and we get 45 degrees. Okay. I'm going to draw this here just in case you're interested. You don't have to do this. Right? But this over here is really that 135, 135. This is C here. This is also C. Okay, it's assumed that they're both the same. You just need to find one of them. Right? Trapezoid is 360. Take away the 2 interior angles that are part of the outside here. So maybe I will just highlight this angle here and this angle here, and then make sure they transfer over to that trapezoid which we're cutting out of that octagon. Okay. So forget about the letters, right? These are 2 trapezoids, and the base angles of both of them are different because they're inscribed in different shapes. Got it? This trapezoid is inside an octagon, that's inside a heptagon, so that will change. The steps are the same, but the actual answer is different. Okay, so don't think it's always going to be 51.43, right, or always 45. It depends on what's inside. Okay. All right. Next, so I found A, I found C. I'm going to skip D and go to B over here. So I'm going to highlight that one because it's a new shape, right? We haven't done that today yet. So I'm using the diagonal and the sides all around. Okay, and if you count them, you have 1, 2, 3, 4, 5 sides. This is a pentagon. It's just not a regular pentagon. Okay, so I'm going to try my best here. So I'm going to do the roof. And then these 2 sides, they just go off a little bit. And then down. Okay, so it should probably be a bit sharper here. One here, and one there. And we know that, right, these three here are the interior angle of the octagon, which is 135, right? So we know this is 135, 135, 135. And we're asked to find B, which is the same on both sides. So to find angle B, we start with what? Remember up here, interior angle of a pentagon is 108, but the sum of a pentagon, sum of all angles, is 540. So you start with all of them adding up to 540 minus 3 angles that measure 135. We're going to take those away from 540, and we're going to split that difference in half. That's 67.5 degrees. Notice that I could have had a pentagon in here in this shape before, and the answer would have been different, right? It was because the polygon that's surrounding it, right, has different interior angles. So we found A, we found C, and using this trapezoid. Then we switched over to this pentagon here. Right, we switch over to the pentagon. Not a regular pentagon, but it's a pentagon nonetheless. and then you find that there. Now we're going to find D. Knowing again, right, I'm going to go with a red pen and go all around. We know that if you focus on the octagon here, at this vertex, that whole thing is 135. Right? You found out here that it's 135. So we're going to go 135, subtract C, which we know, right? Because it's the same here and here. And we're going to subtract B, and that's going to leave us that little sliver there. So to find angle D, we go 135 minus C minus B. I'm just showing you what's happening here. Don't think that this is a formula, right? It's just what's happening. So angle D is 135 minus 45 minus 67.5. So that's 22.5 degrees. And again, right, in this case, all three angles along this vertex here are quite different, right? C, this is 45, this is 22.5, and B is 67.5. So they vary greatly at that point. All right, so there are your answers. Right, so we have a nonagon. You find the interior angle, which is corresponding to A. Then you focus on D, right, which is the base angle of this pentagon here. So you get 60 there. Then I shift my focus to B here, which we know both of these angles will be the same. It's an isosceles triangle formed here, right? So the base angle of that triangle is 180 minus 140 divided by 2, which is 20. The last thing I do is C, which is between the diagonals, and you get 60 there. You just go 140 minus B and D, the ones that are on either side of that sliver, and you get the 60 there. And I believe I posted the key to this anyways on, yeah, I did. So you can always check the rest of the questions there if you're not sure. All right. So we'll put this aside for now. I mean, if you want to keep working on it, I'm not going to stop you. But now there's a booklet that I gave you at the beginning when you got all your handouts. Okay, so I'm going to show you what that one looks like. It's this one right here. Okay, and I would basically ask you to work through this as a review. Okay, some of them are very easy, right? Like you can look at the first one there. X is what? Well, obviously it's a supplement. But please always show me the work, right? X is equal to 180 minus 55, and then say X is equal to this. Don't measure angles, they're not drawn to scale, okay? So if you don't have this booklet, I will also look for it and post it. And so you basically have the rest of today's class to work on that. I already have the answer key and the worksheet ready to be posted, so you can always check how you did. Maybe if I can draw your attention to questions like, starting at question 12, something like this, right? You have like parallel lines and then a transversal crossing it, like actually two transversals here. Always justify and explain how you got that to yourself, okay? So did you use corresponding angles? Did you use vertically opposite angles? Did you use alternate interior angles? All of that, explain that, okay? So you're not just finding the numbers. Same here, right? Like the lines with the arrows, right, are parallel. So I'm telling you these two lines are parallel. So find the rest, right, in that shape. So that's question 14, for example, right? And then if you get further back, you're going to get some inscribed shapes, right? Like you're going to get, if you go to 18 or 17 here, everybody go to 17. Now that I see this, I need to clarify. They haven't inscribed yet, right? So watch this. You find X and Y, which is essentially the interior angle of the polygon, and X is the exterior, right? That one you should be able to do using formulas, right? But then it says calculate the angle PSR. So watch here. You start at P, then you go to S, and then R, right? So they're technically asking you to connect it like this, right? To connect P and S. And they're actually asking you for this angle. So if you want to call that, A or Z or whatever, if you want to have a lowercase in there, by all means do it. Okay, like don't think you have to stick with the 3-letter notation, but you have to know where to go if I gave you that, right? Like, oh, it's right here, right? And so you might have to inscribe yourself, okay? All right, that's it. That's enough of me talking. I will post this and the answer key. So if you, for whatever reason, misplaced this, you can get it, okay?